Well, I hope you still enjoy to my presentation, but of course, slightly different. But some part of this one, of course, I already quote in my previous presentation. But this one, we're talking of valorization of Indonesia bioresources. This is most of the same. But I will talking about industrial symbiosis and circular bioeconomy. This is a very hot topic in the world. And particularly, I like to mention about bioeconomy. Most my fellow Indonesia, I think if you're watching television, most of the time they will say circular economy, but not bioeconomy. This is very important to mention because as I will explain later on, because if you say just circular economy, actually it's very good, of course, but it's not sustainable. So what my presentation will be, there is a introduction. I will talk about symbiosis industrial, and I think this is at least different than the previous presentation. And I'll talk about circular bioeconomy and biomass conversion, valorization, then integration of biomass production and biomass conversion using biocascading. In the end, I will talk about conceptual design of industrial symbiosis. So why so important to mention about this circular bioeconomy? And since 200 years, we have been an industrial area with fossil-based linear economy. Of course, over the last 15 years, a significant reduction of both poverty and inequality between rich and poor country already reached. But again, poverty and inequality are still at an issue, even for developed country. It's important to mention. And the most important, we already use a full 1.6 times the sustainable level of resources in our planet. And that's the reason why I try in many opportunity to present this circular bioeconomy. I've been invited many times by different institutions in this country, but I say, well, I'm interested to introduce circular bioeconomy because I think it's very important now because we have this problem of global climate and global warming. So what is actually, again, I just repeated it, linear fossil-based economy paradigm that escalating resources use, global environment degradation, and unprecedented human-induced climate impact. Scientists believe we are facing now this virus somehow also related to the human-induced climate impact. And in many publications, they had been mentioned that out of this they have some indicators in the world, 9 planetary boundary, climate change, loss of biosphere integrity, land system change, and altered biogeochemical cycle already passed. Well, therefore, climate change and biosphere integrity is very important to realize as a core of our boundary. Let's look at on this slide. So this is the world population that increases dramatically, and the most important, let's look at also the middle class. So the middle class also increased. So what does it mean? That in 2030 the world will need to produce 50% more food, 50% more energy, and 30% more fresh water to meet the need of the growing population and middle class in 2010. So again, have been so this one. So Indonesia and those countries in this area can play important role how to produce that food and a different kind of product. This I like since I'm now teaching in bioengineering that I took this one. The earth actually is bioregenerative. Plants, animal, and especially microorganisms regenerate, recycle, and control life necessity. And this quote actually come, if you read the book of Schrodinger, What is Life, then you can express one. But the most important to mention, because this is the basis of industrial symbiosis, in biology, natural symbiosis is often defined as a relationship between individual of different producer. What you call it, producer, consumer, and decomposer. So I use this word on the way the development of bioeconomy and bioindustry. So of course we have to increase the producer, we have to increase the consumer, but it's also important to increase also what we call it the composer. And this one I've already talked. I will make. So what is symbiosis, industrial symbiosis? That's exactly why I quoted before. Industrial symbiosis is the process by which waste or byproduct of an industry or industrial process become the raw material for another. And this one actually inspires by biology, I just mentioned before. This is inspired by this one. And of course, if you're more close to the way nature works, that's, we live the way we have to pursue. The symbiosis exchange then in the company among different entities collectively to mutually beneficial connection among traditional and connected organizations. These connections are based on the exchange, transaction, or sharing of resources such as material, energy, and water. And already, what is a circular economy? Circular economy, of course, there is slightly change all the time. What is circular? But in general, to keep product, component, and material, and their highest utility and value. This is important word: highest utility and value. And then I will emphasize this one. If we are only focused to the highest utility and value, and you forget how to keep utility and value, just make it very simple. If anyone try to keep utility and value, but utilizing fossil, that it doesn't have any sense about circular economy. And that's why we need bioeconomy, production and utilization of biological resources. And I think this is emphasized, you can read it, but I try to put it because copied from different sources is very important. Bioeconomy go beyond objective of circular economy. Yeah, circular economy only focus on the product and services functionality. And yes, but when you talk about biomass, we talk about bioeconomy, that CO2, water utilized, agriculture, process and other thing. So combining the circular economy and bioeconomy, that we call circular bioeconomy. So how we can evaluate or criticize it? So what actually, when we talk about circular bioeconomy, what should be done? The circular economy, how it can be done through the bioeconomy. So if someone try to proceed with circular economy, but by utilizing fossil, it doesn't make any sense. I really like to this book of this I quoted from Jean-Pierre Charles. And for me and those engineers, that's much easier to study about this bioeconomy, circular bioeconomy, because we know in technosphere, that we call it, thing that then we have two things, the technosphere, but also we have biosphere. The only system that can reduce, of course, still the entropy positive, but by reaction CO2 with water to produce carbohydrate, that we call it negative entropy. But technosphere never involved in the negative entropy. That's why we have to combine technosphere with biosphere to keep the world moving. And this is very easy to see this one. Now, this is the technosphere, and this is the biosphere. So we have to combine the technosphere with the biosphere, because the only system in the world can have part of negative entropy in this biosphere. It's very, very important to mention. And how it happened, of course, by utilizing the solar energy. This is always I teach my student when I teach the thermodynamic. It's very important to realize how important the biosphere and how important any activity that related to agriculture. Yes, because in that place that you exercise the entropy negative. Well, then very, very easy to see that, as you say, okay, this is technosphere. Of course, in any activity of technosphere, we need the input from biosphere. I like to mention a little bit about this, Jana. People sometimes forgotten when you say fossil, you got the coal, oil, but actually coal and oil million years ago also coming from the biosphere. So that's why we need the biosphere as a source, but also we need also biosphere as a sink. So we cannot escape from the biosphere. So it's important not only in the circular economy, they only talk about this one, but they forgetting about this one. So we need also input from outside, but also we have to take care also environment from the sink, from the waste we produce. Right. Okay, so in that one we have it showed as primary and secondary. Let me, because of time constraint, let me focus on biomass conservation, and I already mentioned before. Of course, then for me, I used to be chemical engineering, and now I moved to biological engineering. And for me, it's nice to have experience both thermochemical conversion of biochemical conversion. We can do both. And I can show you later on, most of in our publication with Mr. Abdul, Yusuf, because we try to combine of them. We try to combine both of these one as a preliminary, as a pre-treatment before you go to one from thermochemical. We have pre-treatment in biochemical, but on the other way around, we use the biochemical conversion before we go to the thermochemical. That's essential of this presentation. Okay, of course, there is, we are already experienced all this thermochemical conversion with direct combustion, gasification, pyrolysis. And I'd like to share to our friends here, because a long time ago, actually, all these things we started in Indonesia together with the University of Twente, Delft, later on Groningen. But the problem with us, we never do the research like the one conducted in Europe. So we started long time ago, this thing in Indonesia. Of course, I conducted my PhD in gasification later on, but we know this other one, anaerobic. There is technology. This is thermochemical and biochemical. Why I mentioned this one? So after 30 years of research in Europe, that we started in Indonesia in 1706, they already reached very mature technology that can produce different kind of product. Okay, let me briefly introduce you to gasification. Why I introduce it to you, I now work with a friend from United States that continue, but they're looking for someone who knows gasification, because there now they follow the way in South Africa how to produce fuel through gasification with Fischer-Tropsch. And they come to me. First, they come to me, as I just mentioned before. They already able to synthesize jet fuel or any fuel from ethanol. But later on, they said, "Come to me. Why don't you go through gasification? Because we have technology." They said that also they go to this. I mean, it's not a new technology; it's only technology. But usually, like the one Mrs. from Malaysia, usually only for the large scale, but now can move to small scale. They can produce also biofuel through gasification. I say to them, welcome, I will facilitate you that we can produce jet fuel or any kind of fuel from gasification. This kind of thing they have implemented in Sasol in Africa, but now in the United States, they do it for small scale. Okay, there is a lot of things. I believe later on, Eric will explain this one, how you can convert main sources of biomass to become many different kind of product. But I saw you here, Eric, and me. So in the late 2000 that we developed this one product, different kind of product from this one, and then we have a project with this product. So then we can focus. There is, I believe Eric will mention about one, but if you like to focus a building block, we can focus for this 12. So this is my presentation. Other thing, of course, there is my colleagues, my co-authors can present all these things, but in general, I just mentioned before. So when we do research about kayu putih here, what's the main thing that we have a pre-treatment using like microorganism. By having this pre-treatment, then we can increase the productivity of distillation. They have the oil, but also, well, not really reduce the biomass, but in general, that's the idea. But the waste also they can utilize for rearing the black soldier fly to produce larvae. This kind of thing implemented to many different kind of biomass. Okay, 15 minutes. Okay, I just look at for the clock, the hour. So then it's important, and also the idea to integrate the biomass production and biomass conversion. I think I just mentioned before why some people on the palm oil still poor and some so rich, because those who get rich, they already able to integrate biomass production to biomass conversion. But those who are not lucky to have it, they sell their biomass to the big company, and they never have an opportunity to utilize their waste that can be put back to the plantation. So it's important to integrate the biomass production and biomass conversion and using biocascading. And this is okay. I think this is opportunity for me to share in this forum. I only saw this one to many of my students, but this is first time I saw it in this forum. So when I moved from chemical engineering to science, I will look at what actually is studying by all these colleagues in science. Then I found this Francis, that one is the discoverer of double helix. So in science, they said, if you want to understand function, study structure. This is science. To understand, this is a quote from Francis. So when I look at this one, of course, I've been working in design. I said to my student, if you want to create function, design structure. So I wrote this quote after very famous people, Francis has said it. So what's the main task of engineer is to create function. By what? By design structures. I still remember our colleague, the chairman before, say, you're pencipta, you're a creator. Yes, we are creator, but we are creator of function, not creator of material. So we are create function by design of structure. So it's important for me to explain this one, because all my presentation actually what we design. So we design something based of question, what and how, and who and why. So in the old time, only people think about how and what, but of course nowadays engineer, everybody have why you designed that one and for who you designed that one. It's important that we keep this one. This is of course from the book of a very famous book, Seder, that also written by one of my former students. This is the best book of design in the world. One of the author, one of our former students. So, and then I like to quote again from the book, what is actually what is our design? The design is one of the greatest challenges in the process design involve the synthesis of configuration. The synthesis of configuration. What kind of configuration? So many kind of processing that we construct or we design such a way to have a synthesis of configuration. It's very important to realize. So the process synthesis here is meaning that many kind of process operation are configured into flow sheet. So in process design, flow sheet is one very important thing, and was performed from experience gained in a similar processing situation with little formal methodology. This is very famous book. I read this to my student. You have to exercise to have experience that you already experienced something that have success story. Then based on success story, that you can improve yourself to make or to design more complicated design. All right. Okay, then based on this one, we know that the main process is the reaction, separation, and other thing. Then I will not go to that more in this case. But I say that when you talk about cascading, I already mentioned it before, that we have to focus to produce fine chemical, and that is, sorry, it is fine chemical, food, feed, fiber, and fertilizer. And producing biofuel from biomass should be the last option. But many researchers already focus. I did my PhD or my research on biofuel, but I realized it's important first to realize there is another many product that can be utilized before we are focused on biofuel. Okay, and as just mentioned before, then what actually when we integrated the biomass production with biomass conversion, actually what we do exactly like natures do, we create a producer, we create the composer, but we create also consumer. So based on this one, then let me explain, I already mentioned before, this is the first experience we conduct and we publish it, how we can convert the citronella to become biofuel, but the waste also it can be utilized as a feed for the cattle. And in this publication, we can increase productivity of milk from the cattle from 10 to become 13 liter a day at the time. But also we utilize also the cow dung here, cow manure here, then it produce also the biofuel as an input for distillation. Based off this experience, then we develop many kind of different product. But let me explain this one. Then why then we focus on then here. This is explanation about this one, but I already mentioned this one before. But I like this one. That's why no poly. As I said, that we write down all this what do you call it strategy program from the ministry about this one. Yeah, of the sustainable development. But I like this one. No policy, no matter how ingenious it is, has any chance of success if it is born in the mind of a few and carried in the heart of any. From my experience, then I try to introduce this policy, the government policy, right away to the farmers, and I enjoy having seen the success of the farmers. Okay, now then, after having this one, conceptual design of industrial symbiosis, then I focus on rice crop, cassava, and palm oil in the end microalgae. Why the rice crop? Because we have plenty. First, then we can say that we have focus on starch or carbohydrate, lipid, and secondary metabolite. So when I talk about alga, here later on, I'm talking actually mainly on the secondary metabolite, vitamin, antioxidant, other things. But when I talk about starch, we talk about sugar from and this one. So this one we focus from rice, and then we already publish also quite few on this one. Of course with the rice, but brand many other things we can produce. Of course, some silica on this one and other. But this one, then why in many time, in many opportunities, I always thinking about cassava. Why cassava so important? Because it's one of the plant that is very efficient as a biological agent in transformation of solar energy into chemical energy. So this is the plant I grow in, as I mentioned before. Yeah? So at the time, I make a joke at the time, why are people south and north of Sudan and they are fighting each other? Because in the south is Christian people, in the north is Muslim. They're fighting because they're fighting for water. And I say to my friend, Muslim person, I say, why don't you go away from the Nile? And we go away from the Nile. They say, I believe there is water out there. And we pump the water only 20 meters. And we grow first alfalfa. So, and then alfalfa can pumping out the minerals. And then we make compost of this one and we grow this cassava. So, and then people say, no, we're not going any height. But in general, average, we got 15 kilogram per tree. This is 10 hectares at a time. and then we can produce 150 ton. And then we reported to the chairman of Army, General Martin Lucas. But then at the time, then we, instead of producing a gas fuel, jet fuel, then you eat it for as a food for the people out there. So I think it's very important to realize that it's very important that we focus also from start. And I have now one student in ITB that he produced isobutanol. Why isobutanol? Because isobutanol have a high heating value compared to ethanol, because ethanol only 65% of the gasoline, but this one close to 90% of ethylene. But also we do a modified cassava. But also the most important, we are moving now to hydrolysate an enzyme from the leaf, but to make also biocomposite. Okay, I mean, I'm not going to deep this one because our co-author will present it in this conference. This is the idea. We can produce different kind of product, but I put this one mainly glucose and organic acid. So there have been a lot of discussion asking me, why don't you focus?
Prof. Robert, I'm sorry, Prof. Robert, for interrupting. Is it possible that you can speed up your presentation?
Yes, yes. There's another only 3 slides more. So then you can produce organic acid with very high value. And then we move also, it's very important to make palm oil. As I mentioned before, of course, there is already, they produce also CPO, but in my opinion, you should try also utilize anything, this CPO, and then also we take the secondary metabolite, and this is also, then you can also kernel oil, then you can pyrolyze this one. Then you can utilize this one. But the most important, now we already going to direction that we can try this most of the process here in Indonesia, they utilize thermochemical, but now you move to the biological process by utilizing energy. This is again like the one our participant from Malaysia. We try to miniaturize the processing here. Okay, later on, of course, I already mentioned about this and move to the alga. Why alga is important, not just for the oil, but for the second metabolite. Concluding remark. Let me share you with this one. This friend of mine that I saw you receiving the president, this land had been ruined by company, million hectare of this one. So now we ask them to go out, and then now we try to growing again the forest here and selling the carbon credit. And you look at this one, this is the animal. This is orangutan. They had been the induk, the mother parent, they have been killed, and he's taking care of this one. So by having taken care of this one, now he have investor that to reforestate again this land, 1 million hectares. We start with 100,000 hectares, and we're going to take the services. And this one also, 2 years ago, we already, this is land, a lot of sodic soil here. So we improve also the sodic soil here. So my last quote is, ultimately, the futures of a natural system depend not on protecting from humans, but on its relation with the people who inhabit it or share the landscape with it. With that, thank you, Mr. Chairman.